In section 2.3, we're going to talk about applications of quadratic equations. So in section 2.2, we solved quadratic equations. So in order to do this section, we have to be able to solve so that we can solve these word problems. One very common application of quadratic equations is the Pythagorean theorem. And what the Pythagorean theorem says is if you have a right triangle, and I've drawn you a right triangle right here, it's a right triangle if you have a 90-degree angle. So one that comes together, two sides that come together to form 90 degrees. The Pythagorean theorem says this: the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So let's label what we have. We have an A here, and this is a leg. I'm going to call this down here B, and it's a leg. Okay, so no matter how your triangle looks, whatever two sides come together to form that 90-degree angle, those are your legs. Then, the side opposite that 90-degree angle we call side C, and it's the hypotenuse. Okay, so example one of the legs of a right triangle is twice as long as the other leg. Let's stop there. When we have these word problems, draw yourself a picture. Even if it's not to scale, draw yourself a picture. So they're telling us something about the two legs. So we know that one leg is twice as long as the other leg. So if I let this leg right here be x, because I don't know how long it is, this leg down here is going to be 2x. It'll be twice that long, even though it doesn't look like it. If the hypotenuse is 15 inches, how long are the legs of the triangle to the nearest tenth of an inch? So what we're looking for are the legs of the triangle. Nearest tenth is 1 decimal. So watch your rounding really carefully. Okay, if I go back up here, because I totally forgot to give you the Pythagorean theorem, so I am so sorry. We have Pythagorean theorem here. What it says is if you take the leg A and square it, and you add it to the other leg B and square it, you get the hypotenuse squared. So if I take that formula and apply it down here to what I have, one leg is x, and I'm going to square it. The other leg is 2x, and I'm going to square it, being really careful, equals 15 squared. And then I'm going to clean it up, and you'll notice it'll become a quadratic. So x squared right here just gives me x squared, plus this is like 2x times 2x, so that's going to become 4x squared, and 15 squared is 225. So remember, it's not 15 times 2, it's 15 times 15. Okay, on the left, combine like terms, you have 5x squared equals 225. Now you'll notice in this one, we have an x squared term, we have a constant term, but we don't have just a regular x term. So if I have an x squared term with no regular x, I'm going to solve this one using the square root property. Keep in mind, when I do the square root property, I have to get this x squared all alone on the left-hand side by itself. So as it is right now, it has a 5 with it. So I need to get rid of that 5, and I'm going to divide it. Remember, we do not divide x out, just the coefficient. 5 on both sides. So that's going to leave me x squared equals 225 divided by 5 is 45. Okay, so the x squared tells me I have two answers. To undo that square, I'm going to square root it. If I do it on the left, I do it on the right, and we put that plus or minus out front. And they told me that I can round to the nearest tenth, so I'm going to actually plug in the square root into my calculator when I calculate this 45. So second square root of 45, and I get 6.7. And technically it's plus or minus 6.7. Now, if we're looking for the length of something, you cannot have a negative length. So it's just going to be the positive 6.7. So one leg is 6.7 inches because it's measured in inches. Now the question is, if I know one leg, how am I going to find the other leg? So you'll notice this leg right here was X. To find this leg, I already know X. I'm going to take 2 and multiply by this 6.7, and this will be our other leg. So 2 times 6.7, if you plug that in your calculator, you get 13.4 inches.